Is, I don't know what the plan is, but has someone or will someone inspect the welds? Who's qualified for that if you're putting this into actual racing?
So our welds are supposed to be inspected not only by our team thoroughly, but once we take it to competition, someone will inspect our weld as well.
Okay.
And we also have test welds that also get taken to competition. There's a 90-degree, like a T-shape. We basically, they require us to take weld samples to the competition. So 90-degree and at a 30-degree. So we did when we went to competition in October, we took some test welds and we weren't able to break them actually. And those were Delbert's welds, so I think you did 2 or 3 passes on those, right?
Yeah.
And then, yeah, so our current chassis doesn't have, it has 1 full weld on the welds, but we'll add more. It should, 2 to 3 welds should be enough to.
Yeah, are you planning on sizing that so that you know how thick the welds need to be?
Yes, we do have contacts to try to help us out a little bit more with the welds since we're not fully qualified for it.
And along with that, yeah, like at competition, they look at the welds and they also have X-ray machines to be able to test the tube thicknesses and the welds.
You had mentioned the frame, or at least part of it, whenever welding it together was in tension. Do you feel like the frame just sitting there, is it under stress?
Not as much, I would say, as the current one. It really is eye-opening though to see like how the metal, even not that much force onto it does put into stress. But I think from it being, even like the weather, like for it being cold, like it's definitely changed shape just slightly. It's warped a little bit, and along with the heat from the welding has as well warping it a little bit. But it's most of them. It's given that it will do that, and that there are going to be some inconsistencies like that. But overall, I think it's the yield strength and the tension or the tension strength stuff for the material will exceed that. Will handle it. We also took the current car, and had facilities roll it over a couple times, and it didn't even budge or anything. So.
We as well had a standard block about 2/10 of an inch, I believe it was.
Oh yeah.
And we checked our levelness with our with the for the actual chassis. So we would lay it on the flat concrete and try to fit that underneath. If it wasn't up to our standard, we would take it apart and redo it again.
We did do that with the front nose before we did a full weld on it, just so that because it was slightly off, so we were able to grind it down a little bit, take it apart, and redo it. So. Any other questions?
Will it still be 40 pounds lighter with the supporting numbers that y'all plan to add from the previous to the new design?
So that should add roughly around 10 pounds more, just about. There really isn't much more to add to it.
And then is 30 pounds still acceptable to have lower safety factors? Like is the weight savings from that worthwhile for the lower safety factors and things like that?
In the end, it is. The first car was built more of a tank, if you will. So it was able to withstand a lot more. And the material 4130 is able to actually withstand a little bit more than any normal metal. So it's really hard to dent. So we were able to take off quite a bit.
Through that.
Yes.
I know that Baja gave you all 2 different types of materials to select from. Can you talk about what went into that decision of choosing A or B?
So kind of going into that decision, we kind of used the first year's teams, their reports on what they turned into Baja, and as well as their Capstone presentation, kind of see the difference on what they wanted to use. And it was just a lot easier to use 4130 due to we'd have to add a lot more support to our other, with other materials since it wasn't able to withstand, the stiffness of it.
For future capstone projects that work on the Baja car, what would you think would be next for it? Would the chassis continue to be focused on or something else?
Our chassis, yeah, probably our chassis is pretty much up to date. We did take a lot of inspiration from what we saw at competition. We really looked at a good dozen cars probably. So we try to make sure that this car could be used up for 5 years, which is what Baja is pretty much, what they allow you to use your chassis for. So for the chassis, I think it'd be good. I think the next improvement would probably be either, drivetrain, getting a gearbox, or, a little bit more eco-friendly seat. Ergonomic seat, that's what.
Did you utilize those materials that you used on the unvender and your final design? Yeah, we did use, I think the one that we were unbending on that picture was, the A-pillar. So we were able to get it back into place for like where it needs to be. Our first bend was actually perfect. Like we were kind of nervous going into it, because I was part of the team that helped do the A-pillars this last February, and it was stressful, but, so we were kind of nervous going in, but we bent the first one and it was perfect, and that gave us some confidence, and then we bent it too far, the other A-pillar too far. But, yeah, we were able to bend it back. We did heat it up a little bit, so it was a little bit easier to bend, and, once it got cool though, it was harder, even just to move it those, I think it was like 2 or 3 degrees off, maybe
Yes.
2, and then we were able to get it back to that one. It was like within a degree. We were like, yeah, we'll be able to meet the rear hoop and the front on the nose. So yes, we did use those.
And so no concerns at all that the integrity of the material would compromise?
No, the material's pretty strong. It's like there was times where I would get frustrated, just wanted to bend it, but it's pretty strong. It does definitely need a bender, and like even some of the side members we had to unbend too, and it was a lot harder, but it was because we couldn't have that leverage on it because they were pretty short. So yeah, they're still okay to be on the car.
So, I'm finishing up my design phase this semester and then starting manufacturing phase next semester. So what was some of the biggest challenges in your manufacturing phase that you didn't foresee previously?
I think every team will say this, but the material. We definitely were confident that we would be able to get the material in on time, and it did come with time for us. I mean, we had a month to basically do it, whereas if we had 2 months or 3 months with those semester, it would have been a lot. We would have went a lot slower, basically. But I think with the amount of time that we had the material, we were still able to do what we need to do, finish the chassis. But yeah, those were some of those things that with buying the material that came up were out of our hands in a way. It took like 3 weeks for the guy to even email us back from Texas Alloy, and that's kind of, I don't think it's nobody's fault. Our contact before, he retired, and so we were handed off to another guy, and he didn't check his email. So that was like 3 weeks, and then another 3 weeks, it was like we realized that the department card was expired. So the card should be okay for next semester, the next couple years, but yeah. So I think for sure for me, I think it's material delivery. I don't know if everybody else.
No, I agree with just materials.
For me, I would just say time management, like trying to balance out building something with all your teammates whenever you have like exams the next day, projects the next week, and like homework and everything like that. But that's just simply something every student has to do, I guess.
Yeah, there definitely was a week where we had the same class, but Mario didn't. We just had to tell Mario, like, hey, we gotta study for this test, so we're not gonna be there. But, yeah, time management for sure too.
So that issue with Texas Alloy, were they the only option for a supplier or?
There was, well, you have, vendors that the school, that our department has bought from before. And the two that we were looking at was Texas Alloy, and then, there was a company in Atlanta, Georgia. And the thing with Georgia though is that we knew the material would take a month from when we ordered it. So, but Texas Alloy would deliver basically the next business day, because they deliver stuff here in town to other companies. So even at that, it's free delivery from them too, because we don't need, there's only like 6 pieces of 20-foot tubes, and the company that they order from, they have a lot more, so it was easy for them to just throw it on the truck and then drop it off to us. So we did really want Texas Alloy, just because of how fast they're making.
Material selection, is it required to use that low carbon steel by the competition, or
Yes.
was your choice?
It is required, part of those criteria, just to, they do it so that everybody goes by the same standards, basically, for the automotive industry. And so that it's more of a, I would guess, an even playing field for all the cars. I mean, every car has to have the same engine, so things like that, but, yeah, like, there was definitely other teams at the competition that had, their tubes were smaller, so they use the other criteria or something, but I didn't know. The original team used 4130 steel, and, they had extra material as well, so we've kind of just been working with that material for like the last 2.5 years, so
And what was the carbon content, 18%?
18%.
18%.
Point.
18%? I don't think so.
0.18%.
Okay, just checking. And what's a couple of orders of magnitude among friends? You know, $1, $100, what the heck?
Any more questions?
I was surprised that your design load for the front impact was less than for the braking test. How does that happen? You were showing a displacement, the deceleration displacement for the impact of, I think, 1/2 inch. I think that's correct. And the deceleration distance for the braking test was 5 feet, but the braking loads were way higher than the impact loads. I think, is that right? You can go back and look at that.
Yeah, I know I used two separate equations to solve for that. One I used,
I don't know anything about the equation, I'm just saying, this is your, where's your braking load?
it's,
Okay, and the braking load, just get to the load. So you got 5,000 pounds on the braking load, right? Right, and then, but your crash load is like less than half that. Your front impact load is 2,000 pounds.
Yeah.
So how do you get a braking load of 5,000 pounds and an impact load of 2,000 pounds?
Because my question is, how did you pick the half-second time of crash?
we're assuming it's like hitting something rigid, whereas like the car would.
I mean, did you verify that with crash tests of cars or anything? My guess is that's probably pretty much shorter.
I mean, I just look at I'm a dirt engineer, right? So I don't know anything about designing cars, but I don't know how you have an impact load of 2,000 pounds and a braking load of 5,000 pounds. It doesn't make any sense to me. I mean, that's the first thing I would have said is something's not right there.
Yeah, it might be good. If you make the time of crash shorter, it probably gets performance.
Yeah, it would. Obviously, I don't know how you made these assumptions going into this.
I mean,
I just assumed a very short crash time. I probably should have checked, like you said, with crash test specifics.
And I guess related to a similar question, which is, so you said your goal was to have a factor of safety greater than 1? let's see, for most designs, significantly greater than one's appropriate. So how did you decide what was, I mean, you showed, I think, three or four different analyses with four different factors of safety, but I don't know I don't know if you ever decided what was an acceptable factor of safety. And it'll be different under different performances, but.
I just went off of Baja SAE like standards and regulations, and compared to other schools, most of them use a factor of safety of 1 for like extreme scenarios and such as like front impact.
Well,
and stuff like that.
what are the, because you showed us factors of safety of some, like 30 to basically 1, right?
Yeah.
So why did you decide 1 was acceptable in one of them and 35 is acceptable in another? How did you decide what's acceptable?
Just based off of other schools.
What does that mean? I don't know what that means.
Like,
So what?
I did research, and then Baja SAE provides a course that you can take to do the analysis, and I just applied that to all our simulations, and they all use a factor of safety of 1 just to be safe for like any extreme scenario, pretty much.
I mean, yeah, we did research with, there was other teams that had, like, I guess, papers that
Yeah.
they did on their cars, but, I mean, this
So would
was
you be
previous years.
when you did the static loading, right, was your very first analysis, would you be happy with a factor of safety of 1 for that?
No, not necessarily, but I would just.
I mean, this is what I'm getting at. So I think you used, the factor of safety of 1 you had was for the I think it was the rollover, is that right?
Yes.
So, I mean, why is a factor of safety of 1 acceptable for that, but a factor of safety of 1 wouldn't be acceptable for just the driver sitting in static loading?
I should have been more specific for each scenario, but I was just going off a general factor of safety of 1 for that specific extreme scenario. That is like the minimum requirement,
Why?
just for the safety of the driver and the chassis to be able to continue the competition.
Okay.
I have a few questions about the analysis. And everything is related. So you have a factor of 1, right? But I'm concerned about a few things. You said that you did convergence analysis. Do you have any results from the convergence analysis?
I wasn't able to apply them in the presentation, but I just ran them on the software itself.
Okay, because that's one of the things that gives you like that you can trust in your model, right?
Yes.
So the other thing is some kind of validation.
Yes.
So do you have any validation with any analytical model or experimental validation? Because you said that you made some tests about, I don't know, you put some load, but did you compare that load with your results that you did in the analysis? Or
not that I provided in the presentation specifically, but I was going to provide in the report and include all the data and stuff that I already came up with.
So did you analyze an actual test?
Yes.
So can you describe the test you did?
I just started with like a coarse mesh and ran analysis on that, and then just got finer and finer.
That's a convergence analysis, I'm saying.
Yeah.
So did you build something, apply a known load to it, measure the displacements or measure the loads and compare it to what you calculated?
Oh, physically, no.
Do you have any plans on doing that in the future?
For future Baja, I would assume they would do that, but for me, not necessarily.
Not for the
Okay.
capstone?
so in the convergence analysis that you did, what was the error that you put?
I can't remember it off the top of my head, but I remember it was like moderate. It wasn't like low or high or anything necessarily, because it was kind of dispersed with all the data.
Okay, but that's actually taking into account with the comment that Bill did related of the safety factor. So you have some error in your simulation. So the safety factor actually has some error in the calculation. So you could actually be below the 1, depending on the error, because you didn't have a validation and you don't remember the convergence analysis. So your actual number could be below for the safety factor.
Make
So
sure to-
that's why those kind of either validation, convergence analysis, all of those things are very important to know if, how confident are you about the results of the analysis.
Okay.
And the other thing that is very, very important in this is, where the engineering that you're doing is because apart from using the software, so using the software is one part, but what you input in the software is the most important, and those are the boundary conditions. And those were not really clear in the presentation, so you have them there, but like for example, I couldn't see where were the supports or how you decide about the support, and they are really the most important thing. And those are your assumptions as an engineer coming from the reality to your model, and that would be like a big difference depending how you put your boundary conditions. Could you just go, for example, for the roll? For the frontal.
Explain us the load, because I was confused about the load that you applied for the rollover, because it sounded like, I thought I heard you said you took the braking load and applied it to the rollover. And maybe I completely missed it, but here's, so you have some load there, and it's distributed over some area, right? How did you get how did you choose the magnitude of that rollover load? And then how did you choose how to distribute it across? I'm assuming the pink arrows, magenta arrows there are the applied loads, right?
Yes.
Okay,
And the greens are the supports.
Yes.
right, so how did you choose, how did you get the magnitude of that load, and how did you choose to distribute it in the fashion that you did?
So the magnitude of the load, I was assuming the maximum force it would endure, like through like all
There's a total force, right?
Yeah.
Where did you get that number from?
the above tests,
From what?
the above analysis.
Like
work.
these, yeah, the calculations, like, that were found from these.
So you use use the frontal, use this one, use 2000